Hi, everyone. Welcome back to Organic Chemistry on YouTube, where we're going to learn everything you need to know about resonance structures in 5 minutes or less. The basics. Resonance structures are needed when a molecule can't be described by a single Lewis structure. This is really important for explaining reactivity and molecular stability later on in the course. So I'm going to give just first an example that describes how to draw a resonance form and how to decide which resonance form is more stable than the other. I'm going to give an example now of a molecule that has a negative charge. From this molecular formula, the first step is to draw a Lewis structure based on what you've learned in class and in the last video. So I'm going to go ahead and skip through that part, but I strongly encourage you to pause the video here to make sure you can draw the Lewis structure correctly. This is one Lewis structure that represents the electronic structure of the molecule. The electronic structure means where these electrons are in the molecule. While this is a perfectly valid Lewis structure, all of the atoms have full octets. There's another arrangement of electrons that can be drawn. And I'm going to label each of these resonance forms as A or B to describe later in this discussion. The main difference between A and B is that the negative charge of A is on the oxygen and the negative charge of B is on nitrogen. Now, these are both perfectly reasonable resonance forms. They all have octets. So you might be asked and will be asked, which is the major resonance form? Fortunately, there are some rules that can help us to decide. So the first thing you're going to do is to look at both of the resonance forms and compare them to see which of them has more atoms with fully satisfied octets. As you can see in this molecule, and as you should definitely convince yourself, both A and B have all of their atoms with filled octets, other than hydrogen, which is an exception. In this case, A and B are a tie in terms of energy. The next thing you can do to decide which is the more stable or major resonance form is to compare the electronegativity and the charge that happens to be on them or not be on them. So in the case of A and B, when we compare these structures, there's a negative charge on oxygen in the case of resonance form A, and there's a negative charge on nitrogen in the case of resonance form B. Since the negative charge is on oxygen in A, and oxygen is a more electronegative element, it stands to reason that this negative charge is more stabilized by being on the oxygen over the nitrogen. And that preference for A means that A is the major resonance form. If the two resonance forms are also a tie in A and B, then the next step is to compare whether there's a charge separation. Are there positive and negative charges on the same molecule? Those that have less charge separation are more stable than those with more charge separation. Okay, and that's a wrap on resonance forms. Hope you learned a lot in the last 5 minutes. Tune in next time.